Okay, under statistical estimation, now one of the aims of statistical estimation or interference thing is to estimate the value of a parameter. Now let us say mu. Mu is nothing but your mean of the population, which is based on the calculated value of the corresponding sample statistics. That means using the sample mean, okay, I'll be trying to estimate the population mean. Okay, so there's a reference between these two. Now, there are two techniques which I can implement while performing your statistical estimation for example, your population mean, which is I think Shubham Khare can switch off his video, please. It seems Shubham is in a market. Shubham? Okay. So as I told you, there are two types of estimation which can help me, find out the corresponding or estimate the corresponding mean of population or standard deviation of population depending on the sample statistics. Okay. The first one is your point estimate. Let us see the point estimate. Now, in case of point estimate, we use a single sample value to estimate the desired population parameter. Okay, for example, we have taken here the sample mean x bar is considered as the point estimate of the population mean mu. Okay, so we can directly write mu equal to x bar. Okay, here it is a very simple technique, you can say. The majority of the technique, the type for estimation which we will be using will be the interval estimation, wherein we may get to correct the value of a parameter, okay, at a particular interval. Okay, say might be from a point from say x1 to x2, we might have done it. Okay, if you remember, from a particular range from one point to another. Okay, that is nothing but your interval estimate. So let us see the definition. The interval estimate, we can use an interval estimate where the estimate value of the population parameter is expressed in terms of a range of values. Okay, so from one point to another. Okay, and please remember, whenever we construct, if you remember the bell curve, say from x1 to x2, okay, it will have different types of confidence level. Okay, there are different confidence level. If you remember the percentages which I had shown you for 1 sigma, 2 sigma, 3 sigma, okay, the more the value or the more the percentage, the bigger the interval, okay, that we are confident, more confident that the given value will lie in that particular area under the curve. Right? Now, what we do in this case is, in this method, we actually first find the point estimate. For example, your x bar or your mean of sample, and then construct an interval on both the sides. So we have the right hand side and the left hand side, that is the negative half and the positive half of your curve. Okay, so we plot the 2 points on two extreme points, okay, and within which we can we are reasonably confident, you can say, my true parameter or my population mean will lie between this two range, say x1 and x2. And as I said, the bigger the range, okay, we are more confident, okay, or the degree of likelihood, that is known as your confidence level, and the corresponding range around that particular sample statistic, that is in this case, it is x bar, that is your mean, is known as your confidence interval. Okay, so you'll find in the problems which will be taken, we'll be getting the confidence level given to us, using which we will be finding the various values, either mean or standard deviation or whatever is demanded from the question. Clear? So if I have to represent this whole thing, if I have to represent this whole thing in a diagram, let us see that diagram first. I just wanted to show you that. This I've already told you, greater the interval, more likely it is that the parameter will lie in this range. Okay, and this degree of likelihood is known as your confidence level. Let us come to the diagram. I don't want to show you this one. Okay, now if this is my curve, right, and we have this value of x1 and x2, where x1 and x2 are my two extreme points, or my, you can say, once we find out the value of x bar, I'll use that value on both the sides as x1 and x2. So this whole thing becomes my range. Okay, so from x1 to x2, if this is this big the range is, I'll be more confident. Let us say this percentage is say 1z, or let us say 2 or 3 sigma, not z, sigma. So 1 sigma, 2 sigma, if you remember the percentages which I had given, uh, if I want say 95% of significance, then the value of z here, there is one z sigma x, you can say this one, the value of z will be 1.96. Okay, and 1.96, you can say 1.96 multiplied by sigma x bar on the right hand side and on the left hand side together will be 95% under the you can say curve. Okay, so if you represent this whole thing like this, your 3 sigma 3 sigma x bar will be around 99.73%. So it covers 99.73% of the area under the curve. And this curve is your normal curve, okay? Normal curve of distribution. Clear? As we have already seen that in case of samples which is of a larger number, greater than, I said, greater than 30, greater than equal to 30, we can consider it to be a normal curve. Fine, let us go back. Okay. So the two types of, you can say, estimation type which we'll be using, one will be the point estimate and the other one will be the interval estimation. And we'll be using interval estimation more compared to the point estimation. But because point estimation is also a part of interval estimation, okay, so when we are actually using this method of interval estimation, we are first supposed to find the point estimate value. Okay, and then we have to construct the interval on both the sides to go ahead and find the required value. Okay, so both are involved whenever we are going to solve the problems. Now there are two things which we'll be covering. The first one will be the interval estimate of population mean. Okay, which depends on your, you can say, the population variance, right? Provided it is known to us. So this one, let us see that. Okay. Now, using the limit theorem, which we have already seen, for a large sample, your sample distribution of mean approaches a normal distribution. Okay, as I told you, if it is more than 30, and we have mean of sampling distribution equal to the mean of population. Very important. That is, your mu is equal to x bar. Okay, we can also, like for example, we can also take x double bar in some cases. So mean of sampling mean, okay, is taken as x and we put double bar on top. Clear? And if I have to say only sample mean, then we take x single bar. Clear? So we can write this as x double bar equal to mu, and we can write the standard deviation of distribution as sigma x bar. Okay, and it is called as a standard error of means. Okay, it is called as standard error of means. So these two things are important. x double bar equal to mu, and your you can say sigma x bar is your standard error of mean. We can transform the sampling distribution into a standard normal distribution for the function of say z. Z is equal to, we can write x bar minus mu divided by sigma x bar. Okay, because now standard deviation of the distribution will be taken as not as sigma x. Okay, will be only sigma will be taking as sigma x bar. Okay, so while writing the function, this function is very important, which we will be using while doing the calculations. Okay, so using this function, we can always write as mu, solving this one, we can write mu is equal to z into sigma x bar. And when we take x bar on the other hand side, we can easily write just please 1 minute. Okay, so if I solve this and I want to find out the value of mu, okay, we can easily write mu equal to x bar minus z sigma. Okay, that will be the function which we can get from this particular standard normal variate function z. Okay, now mu can also fall within the range. Okay, the value of you can say will be between plus and minus of z, right? So on the right hand side and on the left hand side. So if it is equidistant from the x bar, like in the previous example or the diagram which I showed you, this one. Okay, what we can write is, we can write mu equal to, so mu equal to, we can write x bar minus z sigma x bar. That means if I want to find out the actual value, it's not always minus, it will be between a range. If it is between the range, then mu should equal to x bar plus minus z sigma x bar. Okay, hence we can say that the mu lies between the negative part on one hand side x1. Let us take x1 as x bar minus z mu x bar, and x2 will be nothing but your x bar plus z sigma x bar. Okay, so the both hand side x1 and x2. So the range will follow like this, and remember, we'll be having your mu as equal to x bar plus minus sigma x bar. Now this is especially when we are making use of the interval estimate and not the point estimate. Whereas for the point estimate, we'll be only using this function, the previous functions which we saw for your standard variate, distribution variate, we'll be using that one. Clear? Now this whole thing again, if I want to write it, I can write the range like this. So x1, where x1 is nothing but your x bar minus z sigma x bar, less than equal to mu, again less than equal to x2, which is nothing but your x bar plus z sigma x bar. Okay. Now if I say the value of z is equal to 3, okay, then whole function can change like this, and we can write it this way. We can write x bar minus 3 sigma x bar less than equal to mu less than equal to x bar plus 3 sigma x bar. Okay, so this is my whole range. And as I told you before also, if it is 3 sigma, if the value of z is 3, it covers at least 99.73% of my level of confidence, the interval. Okay, so the confidence interval here will be at 99.73% level of confidence. Okay, so I am very much sure. So I am 99.73% sure that my value of mu is going to lie between that particular given range. Okay. And similarly, if I change this value at say confidence level of 95%. If I make it as 95%, okay, and for 2 sigma it is 95.44%, okay, under the curve. This percentages we have already seen it before. Thus, there is you can say 99.73% of likelihood or confidence that the parameter mu will lie in this range of your x bar plus minus 3 sigma x bar. Okay, and the confidence interval is at 99.73 level of confidence. Now there is one more term, level of significance, which is nothing but 100% minus the level of confidence. Now if I say level of confidence is 95%, then the level of significance will be 5%. Okay, so which is also represented by the alpha sign. So sometimes what happens is to just confuse you, instead of giving you the level of confidence, they will give you the level of significance. Clear? So if my level of significance, if they say it is 5%, now your alpha value will be given as 5% will be represented as 0.05. Okay, and the critical value for significance level of 5% or the confidence level of 95%. If you refer to the chart which I had shown you before, okay, 95% means if you divide 95 by 2, because we are considering both the sides, the right hand side and the left hand side, it will come as 4.5. Okay, and if you refer to the value, especially if I refer to the, you can see the table, not 4.5 please, it will be 45. 90 will be 45. Okay, and using 45 we can put as 0.45 and refer to the table under the standard normal curve and the reverse order and check for the value 0.45, which is the closest one, and the corresponding value of z can be considered. Okay, so if you do that, the critical value in case of 95% of confidence level is around 1.96. Okay, to show you that, I'll just 1 minute, I'll show it to you on the graph here, or the table which get used before. Yeah, here it is. So if I say current slide, okay, so here we can say we were seeing 1.96. So if I look at 1.96, this one, here we go. So this whole thing, now this is not getting correspondence value from here. Okay, now what we can do is we can take 90. So take 90%, divide by 2, we get 45. So check for the value 0.45. Okay, so 0.45 is very close here, this one. Okay, so this whole value, that is, it is coming to is 1.56 or 65, sorry. It's coming to 1.65. Now, there is a website as well, and please always remember it might not match the value which is given to you. So basically, you have to either remember these values, or while they give you a question, they might provide you the value of Z in the question itself. Okay, in some cases, I have seen that the value of Z is not provided at different confidence levels. So for that, in that case, you have to remember that for 95%, the value of Z given is 1.96. Okay, there's a website as well where we can pass the significance level. So if I pass the significance level as 5%, I'll get the critical value of Z as well. Okay, now you won't be getting this chart of a standard normal table while you're solving the problems. Okay, the values will be directly provided to you. Okay, so you need not worry about it. Okay, coming to, okay, this was the slide. Okay, coming back, similarly, as I told you, for 95%, for 99% and 90%, there are some fixed values. You have to always remember these values. For 99%, it is around 2.58 something, or even 575. So depending on what is given to you, you have to use it. For 95%, note down these values actually. 95%, the value for, or the critical value of Z is given as 1.96. Okay. So if I use this, I can find the values of x1 and x2 using the formula and then solve the problem. Okay, as I told you, we also have at 95% the significance level. So if I say 95% is your confidence level, then 100 minus 95, that gives me the significance level. That is your alpha, which can be written as 0.05 for your 95% of confidence level. And if you go to the website, you'll find that it takes the significance level and then calculates the value of the critical, the value of Z, that is the critical value of Z is calculated based on the significance level and not the confidence level. Okay. And there's the reason I cannot directly refer to the standard normal curve chart and get the critical value of Z. Okay. So you'll find it's very close, but it is not exact value. That is what I have noticed while I was solving some problems. Okay. Now this is how it looks like. So if I say 5% on both the side, the two tails, here you can see it is 2.5 and 2.5 here. And the mean curve. So for 1.96, this for value of Z, it is 47.5% on one half, and similarly on the other half. Okay. Now, as I said, at 90% of level of confidence, you'll find that 10% of level of significance. And in case of 10% level of significance, the value of Z is given as 1.645. Okay. And sometimes it is also used as 1.65. I'll just show you that. So note down this also for at 90%, the value of critical value of Z is 1.645, or you can write as 1.65 if you want to round it up. And at 99% level of confidence, or you can say 1% level of significance, the value of the critical value of Z is given as 2.58, or in some cases it's given as 2.575. Okay, up to 3 decimal places. Now, note down some points here. So if we say the standard error of means is given, so this is the formula to find the standard error of mean, where your sigma is the standard deviation of population, and therefore its variance will be your sigma square. Okay, n is your sample size. Now, if I said last time I told you, if the value of n is big in the sense the sample size is large, greater than or equal to 30, okay, then we can say the approximated of the standard deviation, your s x bar is given by s upon square root of n. Okay, so instead of using sigma here, the standard deviation sigma, in case of value of n greater than 30, the standard deviation is denoted by s. Okay, and the function which I'll be using will be s x bar equal to s upon square root of n. Okay, and hence we can say that the confidence interval is given as x bar, and instead of sigma now we can make use of s x bar. So it will be x bar plus minus z s x bar. Clear? And if I say it is at 95 percent of level of confidence, then this can be represented as X bar plus minus 1.96 S X bar. Okay, that will be like this. Clear? Now the interval, you can say your X bar plus minus Z sigma X bar, or for the sample X bar plus minus Z S X bar gives the interval estimation of your population mean, that is mu. And your sigma X bar, or you can say S X bar, represents the standard error of estimation of especially your population mean at the given confidence level or the level of significance. Now, quickly, I'll take one small example because we have covered, I think, lots of theoretical things and the different formulas and the concepts. Let's take one example and we'll solve this. We have a company which wants to estimate the average age of its workers. Okay, and a random sample of 64 workers showed that the average age was 27 years and within a standard deviation of 4 years. Okay, so your X bar is given as 27 and your sample distribution or your standard deviation for the sample, that is your S, is given as 4. Okay, your sample size N, small n, is 64. Now using this, if I have to calculate, and as you can see, the sample size, the value of n is greater than 30. Okay, if it is greater than 30, we can say that it is following the curve that we have, the normal distribution curve. So we can use that and the formula for that. So the confidence interval will be X bar plus minus Z S X bar. So use these values and try to find out the confidence interval, please. What will be the value of X1 and X2? That is what I want to say. So if I want to find X1, X1 will be X bar minus Z S X bar. Okay, and at 95% of confidence level, I have already told you, we have to find out at 95% confidence level. I've already told you the value of Z is given as 1.96. Now, there are two questions which are asked under this. So we have to estimate at say 95% confidence interval, estimate the average age of all its workers. And in the second one, the question is, how will this limit change if the confidence level is increased from 95% to 99%? So we are actually finding only the confidence interval. Okay, nothing else. A very simple example to just find the value of X1 and X2. At 95%, the value of Z, as I told you, is 1.96. So you can just do the calculation and you can share the answer. As I have already told you the formulas, please try it out. I'll repeat, the mean is 27. The value of S, your standard deviation for the sample, is given as 4, that 4 years. Okay, and the value of N is 64 as per the given question. And the value of Z at 95% confidence level, Z is 1.96. So what is the value of x1 and what is the value of x2? The function for confidence interval, as I said, you can make use of x bar plus minus z s x bar. And what's the function for s x bar? S divided by square root of n. We use that function. Anyone with the answer? Okay, let us see the answer then. So as I told you, sample mean will be 27 and your standard deviation for at 95 confidence level, critical value of C is given as 1.96. Okay, to find the value of S x bar, we can use the function S up divided by square root of n, which gives me 0.5. So using 0.5, x1 will be x bar minus z into 0.5. Okay, so here we get the first answer as 26.02. That is my x1. And similarly, if I want to find the value of x2, I'll just perform addition instead of subtraction, and I'll get 27.98. Okay, so hence we can say that the estimated population mean, that is the average age of all the workers, mu, will lie between 26.02 and 27.98 at 95% level of confidence. Okay. Now, if I change from 95% to 99% of confidence level, okay, as I said, 99% confidence level, the value of Z is given as 2.58. Or in some cases, we'll find it, they have used 2.575. Okay, both can be used. And you can do the calculation again for x1 and x2. So this is the final answer for the first one. And taking the second one, if I change 95% to 99%, as I said, I'm going to take the value of 2.58 and I'm not going to take 2.575. Okay, we can find out the value of x1. It is coming as 25.71. And similarly for x2, I'm getting 28.29. Okay, so it simply means that the value of mu, okay, or the average age of the workers will lie between 25.71 to 28.29 at 99% level of confidence. Clear? Now we have only some 1 minute left, more than 1 minute left. So we'll stop here. This one simple example which I took to make you understand how to find out the confidence interval. That's the value of x1 and x2. Okay. When we go ahead, now this was an interval estimation of population mean. Okay. Sometimes, we might not get the mean. We might have to use the proportion. Okay, the percentage. So for that, we have some different formulas. So when we come next, we are going to see interval estimate of population proportion. Okay, and we'll take one more example based on this population proportion. Clear? And again, it is not very difficult. You have to just understand the concepts are more important. If you understand the concept, you'll be able to solve the problems. Fine. So we'll stop here today. And next time when we come, we'll complete, that will be the last session on your probability distribution. Okay, and the next topic we're going to start is Qs, Q theory. There's something in the chat. Thank you. Okay, thanks everyone.